예, 오늘은 펄스포지의 비크롬 투카니 기술 파트너십 이사님을 모시고 반도체 공정 기술 얘기해 보도록 하겠습니다. 이사님, 안녕하십니까?
Hello, thank you for having me.
네. 일단 가볍게 회사가 어떤 매출원을 갖고 있는지 소개를 좀 해주시죠.
So, we're a US-based company. I define PulseForge as a company that disrupts the industry by bringing very innovative technologies. We've been in business for the last 20 years. Since 2022, PulseForge, which was part of Novacentrics as an equipment business unit, was spun out as its own entity because we had our advanced applications and we wanted to spin out an entity so that we can cater from the equipment side to the electronics and semiconductor industry as well. We are a privately held entity. We don't give out the revenue information, but we are privately held by a single family, and we are been in business for 20 years, so we are very well, financially very well situated, and we continue to cater that strength to the customers as we deliver our technology.
회사가 보유하고 있는 핵심 역량은 어떤 것입니까? 기술적 역량은?
We excel in providing high-powered flash lamp machines, and we also bring in expertise from the material science and bridge them together to deliver disruptive technologies for semiconductor manufacturing. Flash lamps are trivial. You see flash lamps and camera flashes, but we engineer technology around flash lamp to deliver high intense pulse light. The intensity of this light can range greater than 50 or 60 kilowatt centimeter square. But we not only deliver light at such high intensity, but we also deliver light in microsecond time scale, enabling non-equilibrium processes that actually opens up a lot more applications, including photonic debonding.
구체적으로 어떤 공정, 어떤 장비에 이 회사의 어떤 기술이 들어가고 있습니까?
Sure. So our history dates back to processing cell phone displays and processing high temperature material on low temperature substrates. Very recently, we have also developed technologies that can use the light energy to reflow components. And very recently, we have been disrupting the temporary bonding and debonding application in the semiconductor market with our technology called photonic debonding.
지금 회사에서 보유하고 있는 그 플래시램프 기반 어떤 이 기술은 기존에 뭐 레이저라든지 그냥 열로 하는 거하고는 뭐 구체적으로 어떤 차이점이 있는 겁니까?
The industry has been evolving with the different temporary bonding and debonding methods. So the optical methods, including laser debonding, has become very popular. The lasers they operate in a single wavelength source, and to a large degree the spot size are certainly limited. What we do is we also bring in an optical engine in terms of flash lamp, and improve its power or power density from the lamp, and take advantage of that high power pulsed light to illuminate a much larger area, and we combine that with an innovative material that serves as a light absorbing layer to achieve this temporary bonding and debonding. By doing that, it helps us to eliminate the need for lasers that requires gas, or it also eliminates the need for additional polymer layer that require laser-specific absorption, which has to be recoded every single time. And most importantly, the innovative light-absorbing layer, and couple that with a high-power flash lamp, the layer ensures nearly 100% blockage of the light. So essentially, we're eliminating any light-based damage to the devices. That's a very important factor that some of our customers experience with lasers today, where the laser light can damage some of the dies.
그 플래시램프 기술은 기존에도 좀 다른 산업 분야에 좀 활용이 되어 왔던 기술입니까? 예를 들어서 뭐 사진 촬영이라든지 뭐 어떤 경화, 다른 쪽의 산업용 경화 뭐 시장이나 이런 쪽에서 좀 활용이 되었던 기술인지 제가 궁금해서 여쭤보는 것이거든요.
Yeah, I think flash lamp technology has been long known to the industry, but flash lamp technology today has been used for annealing thin films or curing printed inks or curing polymers. But there's always been a need for a really high power flash lamp systems, not only instantaneous power, but average power machines that process reliably and be able to achieve non-equilibrium processing capability. And that's what PulseForge effectively addresses. We take the flash lamp that emits light radially everywhere, we design a very unique reflector and deliver that light to a given area with a uniformity of 2 to 3% in the center, right? And that helps a lot of production environment to reliably process the material. It could be for curing, it could be for annealing, it could be for sintering. So that is how we enter the market and how we differentiate ourselves.
그럼 방금 전에 잠깐 얘기하셨는데 LAL 그게 뭐 LAL 캐리어가 이제 한국말로 치면 광흡수층 캐리어라고 얘기를 해도 되는 건지 모르겠는데 핵심은 그 캐리어에 있는 겁니까?
They actually go hand in hand. The development of this LAL layer, it was from 2014 onwards. Conceiving the concept of LAL with the flash lamp technology to separate any kind of electronics has been long researched by our team since 2014 or even earlier, I would say. We brought that idea to the industry. We took time for us to make that combination work in such a way that delivers significant technical performance and make economical benefits to the customer. So it's important to kind of highlight both of them together.
지금 오늘 촬영 날짜가 2월 21일입니다. 세미콘 코리아가 열리고 있는 기간 중에 이제 모셔가지고 저희가 인터뷰를 하는 건데, 이틀 전에 제우스 반도체 장비 회사에서 펄스포지와 협력하여 포토닉 디본딩 자동화를 출시하겠다, 예정이다라고 얘기를 했습니다. 제우스하고도 지금 협력 관계를 맺고 있는 것이죠.
Yes, myself and the rest of the team are working with very closely. Zeus has been developing their unique abilities in this market, and they are in Korean market. We are working very closely with them to bring our technology to some of our customers here and outside Korea as well.
그러면 지금 그 회사는 지금 HBM용 이제 디본딩 장비, 본딩 디본딩 장비를 이제 이미 출시해서 공급을 하고 있는데, 이 장비는 조금 더 개선된 어떤 기술을 갖고 있는 장비로 보여지는데, 기존 대비 이 장비를 활용했을 때는 뭐 좀 매끄럽게 떼어집니까? 아니면 좀 뭐 비용을 좀 절감하면서 뗄 수 있습니까? 어떤 특장점이 있습니까? 아까 뭐 대략 설명해 주셨습니다만.
Of course, demand for memory, especially HBM, has becoming skyrocketing ever since AI, generative AI, and high performance computing started becoming important, right? As you may know or have heard, a lot of these memory manufacturers are increasing their capacity, the HBM, especially HBM output, right? It involves a lot of capex or equipment to accomplish that, right? Mechanical debonding is one of the common debond method has been used, I would say, for HBM manufacturing. But as the scale of this HBM, or the output of the HBM is growing higher, you also need the output of your equipment to also scale. Or you'll end up spending more and more money on the equipment. Some of the tools can deliver 5 wafers per hour or 10 wafers per hour throughput. From the throughput point of view, photonic debonding can easily hit 40 wafers per hour or more, right? So you're comparing one machine of photonic debonding versus almost 8 machines of mechanical debonding. That's one way of addressing the throughput that is really needed for the growth of to fuel the growth of HBM. And the second aspect of it is HBM technology is evolving these days every year, right? HBM3E, HBM4, HBM4E, Now SK Hynix is probably under pressure to deliver 4 or 4E for their customers. And the wafer thickness is always going down. And mechanical debonding has its own limitations. Right? The thinner wafer, as you try to mechanically wedge the wafer pair out, essentially would end up cracking the wafer. Photonic debonding, couple that with a light absorbing layer, enables a stress-free separation of the carrier. And we have demonstrated that we can debond wafers down to 20 micron thickness, or even below, without any without any damage to the device wafers. We are also addressing not only from the throughput side, but also from the technical performance side. Having that ability to debond such thin wafers is extremely crucial for Hbm manufacturers. And that is one of the highlight of the photonic debonding. And most importantly, you need to be also mindful about economical factors as you spend more and more money on producing this Hbm, right? Our industry best cost of ownership, especially lowering the cost per wafer for the TBDB process compared to mechanical or especially laser debonding, has been very attractive to the customers. So naturally, that helps them to produce more Hbm at thinner wafers at a much faster throughput and keep the cost lower. All of these should be attractive to the Hbm manufacturers, and that's what our feedback has been from the customer side, and we're very excited about that.
경제적으로 메리트 있다라는 것 중에 아까 그 LAL 광업수층 캐리어를 활용한다고 했는데 그것은 계속 쓸 수 있는 겁니까?
Yes, that is one of our highlight of the technology. We have demonstrated internally and to our customers that we can reuse the LL coated carriers several number of times, and that has a very profound impact on cost of ownership, especially for cost per wafer when you do the calculation.
Okay. 지금 웨이퍼 본딩, 디본딩 공정 자체는 굉장히 뭐 다양하게 이제 쓰이고 지금도 많이 다양하게 쓰이고 있고 뭐 이미지 센서라든지 이런 쪽에도 뭐 백사이드 일루미네이션 할 때도 뒤집어서 이제 붙이고 하는 공정, 떼어내는 공정도 있고 또 백사이드 파워 딜리버리 할 때도 후면 전력 깔 때도 이제 필요할 거고 지금 HBM 쪽 말고도 굉장히 기대하고 있는 영역들이 많이 있는 것이죠.
100%. I think we are already in discussion with the customers, or customers are adopting our tools in that sector as well, especially for backside power delivery and backside illumination for image sensors as well. TBDB is essential to a lot of areas in semiconductor manufacturing. Naturally, customers have a keen eye for better performing technology and lower cost of ownership. And photonic debonding is today offering that benefit to the customer. Naturally, a lot of customers are curious to test and evaluate and adopt the technology. And we've seen a very good feedback from the industry, not just from the memory area, but also in the other aspects of the industry as well.
오케이. 지금 회사의 출연으로 펄스포지의 출연으로 어떻습니까? 좀 불이익을 보는 기존의 어떤 이런 엔진을 갖고 있는 회사들이 또 있습니까?
That's the nature of the industry. Disruptors are always there, bringing innovative technology. I understand the component of being new into the industry, but our strategy has been, first, our core technology has been production proven, has been in the industry for more than 20 years. Right? So we are not that new to the industry. We have machines running in Korean factories, running in Chinese factories, running in US factories, and running in Europe factories 24/7 today for producing electronics, be it display, be it photovoltaics, be it other aspects. The photonic debonding module or technology is built on the same core platform. So we understand the reliability of a technology. We have studied a lot about how our technology would perform in a high volume manufacturing setting. But still, for temporary bonding and debonding area, our entry is often looked into as a newer technology and disruptive technology. Our customers understand the merits. They weigh the risk out as a potentially new company versus what the benefits they could reap. And we also strategize in deploying our technology with the known existing companies who are in this market, like Zeus is in semiconductor market, right? So we partner with them rather than directly selling the machine to them. We take leverage of their industry connection, like we take leverage of their service setup, sales setup. We partnered that with them and to effectively deploy this technology to the customer. And that's what we've been doing. And it's been very successful for us to get on board with the customers.
지금 제우스하고 어떤 협력을 발표를 했지만 지금 다른 회사들하고도 다 이렇게 공급 논의하고 계신 것이죠?
We have multiple partners all over the world. It is designed that way. It's very common for semiconductor end customers to prefer a supplier. We want to be open to all of the customers, and some customers may like one vendor, some customers may not like that vendor, right? We want to make sure that we have a partnership with them to ensure that we deploy our technology. And Zeus has been an incredible partner, and we see a bright future with them. And as we work closely with them, we'll learn more about them. And as we deploy our technology through them or through other partners, our goal is to make this as a de facto standard, and we'll continue working towards that.
지금 이제 웨이퍼 디본딩 쪽에 이제 얘기를 하셨는데 아까 말씀 들어보면은 예를 들어서 일반 플립칩 패키지 공정에서도 레이저를 이용한 뭐 LAB라든지 이런 기술들이 이제 지금 많이 쓰이고 있는데 이런 쪽으로도 적용이 될 수 있는 겁니까?
Yeah, 100%. I think photonic debonding is one of the technologies that we're deploying today towards advanced semiconductor manufacturing, including advanced packaging as well. Having this ability to deliver light energy to perform work, even our demonstrated technology, photonic soldering, which has the ability to reflow solder bumps or solder paste, right, is very directly applied to LAB. We have competed with LAB technology with our technology, and we bring in not only benefits from the larger illumination, but also benefits in terms of joint reliability. We have demonstrated in several customer cases where our joint reliability with our photonic soldering technology for die attach has been superior, far superior than what you get with a laser debond. And there are several technical reasons for it. Laser lab could be more directed, more specific for a given wavelength, but we also control the IMC formation between them by controlling the light energy as well. So those factors come into play that actually puts us in a much better spot compared to a lab. We are actively partnering with customers in this area. We not only bring just the technical benefits, we also have a good understanding about economical benefits that we would offer over lab, be it in terms of CapEx, be it in terms of operating cost. We are continuing to partner with the customers, and we hope to see a widespread deployment of this technology as well.
지금 펄스포지의 그 플래시램프 기술은 그렇다면은 특허로 보호를 받고 있습니까?
Yes, we have a core IP both for our core equipment and for all of these processes that we talked today. We are the providers of this technology today, the only providers of technology today, and but our goal is to kind of partner with companies like exist in the semiconductor industry to deploy it.
지금 회사가 이제 뭐 스핀오프 되어서 이렇게 설립되어 가지고 몇 년 안 되고 나서 이런 뭔가 상용화의 어떤 이제 올해가 이제 뭐랄까요 그 상용화하고 매출이 이제 크게 이렇게 올라오는 시기라고 보십니까? 아니면 뭐 한 내년, 내후년 정도 가야 또 본격적인 매출이나 이런 것들이 발생될 것이라고 보십니까?
Yeah, so the spin-off happened 2 years ago. We started marketing technology, especially photonic debonding, within this 2 years. We've already seen we've started seeing feedback immediately. We remember before we spun out, we were already working on debonding with other potential beta customers even before spinning out. The feedback from the industry has been very good, and we've already started seeing results this year in terms of customers adopting, and we've made public announcements of some of the customers who already adopted, and we hope to make more public announcements of customers adopting our technology.
이사님 오늘 긴 시간 인터뷰 응해 주셔서 고맙습니다. 한국에 이 인터뷰 보신 한국의 여러 패키징 관련된 설비하시는 분들이 굉장히 관심 있게 볼 것 같습니다. 뭐 또 내년에 뭐 또 세미코리아에 오실 기회가 되신다면 또 한 번 더 모실 수 있는 기회를 갖고 싶습니다.
Absolutely. 감사합니다.
고맙습니다. 네, 네, 감사합니다.
Thank you.
네.